This is lesson 11-4, video 2. I am at the top of page 774, and we are looking at theorem 11-4-3, and I'm going to slant the phone so that you can see the whole thing. An inscribed angle subtends a semicircle if and only if the angle is a right angle. I've rewritten that to say an angle inscribed in a semicircle is always a right angle. Let's look at the picture. Do you see our semicircle? An angle inscribed in a semicircle, that means it goes from one end of the diameter to the other, and the vertex rests on the circle. If it is inscribed in a semicircle, then it is going to be a 90-degree angle. Now, going back to a review, remember that the arc that intercepts it or subtends it is going to be twice that angle, which is going to be 180 degrees. That was just a quick review. All right, let's use this information from this theorem one more time. An angle inscribed in a semicircle is a right angle. Let's use that information to solve for x in the diagram to the right. Let me try to get my book a little flatter so you can see my work better. Okay. We see that we have an inscribed angle in a semicircle because the two endpoints of its sides meet the diameter's two endpoints. So we know that this is going to be a right angle, a 90-degree angle. So I can find out what x equals by setting this equal to the amount that we know that it represents. So 4x plus 6 equals 90. We solve for x and we get 21. Let's look at example B. We want to find the measure of angle ADC in this second diagram. We're looking for angle ADC. So we're looking for this angle right here. Okay, let's look at these angles and see if there's anything that we can work with. At the moment, I notice that angle ADC opens up to the same arc that angle ABC opens to. Do you see that? They share arc AC. That means that we can set these equal to find out what y is because they are equal. They share the same arc, therefore they are equal. So we say 10y minus 28 is equal to 7y minus 1. We do the algebra and we get y equals 9. But that's not the end of the answer, because they ask us what the actual measure of the angle is. So now we've got to plug 9 into 7y minus 1, and we get 62. Let's look at another one like that, or maybe another two for practice. These are the check it out, 3a and 3b. Here we want to solve for z. Well, we see that this angle, this inscribed angle, is in a semicircle, or in half of the circle. That means it's automatically going to be a right angle. So we set 8z minus 6 equal to 90, and we easily solve for z. Let's look at 3b. Find the measure of DEF. Angle, I'm sorry, I said that wrong. The measure of angle EDF. EDF. So we're looking for this angle right here. Notice that the only other angle that we're given information for is another inscribed angle sharing the same arc. Therefore, the two angles are congruent. So we set 2x plus 3 equal to 75 minus 2x. We solve for x, it equals 18. That's not our final answer because they didn't ask for x, they asked for the measure of the angle. Now we must plug 18 in, and we get 39 degrees as our answer. Let's see, I think we're good to keep going in this same video. We just have a little bit more. So let's move to page 775. Y'all, can you believe we're on page 775? We are so close to being done. I'm so proud of y'all. You've done a great job. All right, theorem 11-4-4. If a quadrilateral, I'll do it like this so you can look at the picture while I read it. If a quadrilateral is inscribed in a circle, which this one is, of course, then its opposite angles are supplementary. Now, we're using a lot of geometry review today. Think about what supplementary means. It means that two angles add up to equal 180. So that means D and B are going to add up to 180. And A and C are going to add up to 180. All right, let's apply that information in the example. Example 4 says, find the angle measures of PQRS At first glance, PQRS looks more like a triangle than a quadrilateral, but if you'll look carefully, you'll see that it has a side right here, a little chord QR, and it has another side, another little chord PQ. So these are our opposite angles, R and P, and our other opposite angles are Q and S. And they have asked us to find all of the angles. So we don't have anything to set angle Q equal to, but we know that P and R add up to 180. So let's do that. Let's say 6y plus 1, which is what I've done right here, plus 10y plus 19, which was angle R, equals 180. And now we can solve for y. We can add the 6y and the 10y, that's 16y, and the 1 and the 19, that's 20. Then we continue and solve for y, which equals 10. We go back and plug 10 into each of those angles, and we see that this one is 61, angle P, and angle R is 119. Make sure you've done your math correctly by adding those up to see if they in fact equal 180. Next, we find out what angle Q is equal to by plugging our y in. So we have y squared, which is 10 squared, or 100, plus 48. That's 148. Now we know that Q and S are also opposite angles, and they must also add up to 180. So I simply said 180 minus 148 gives us 32 degrees for angle S, and those are all of our angles for that one. So that's really pretty easy. I think you're going to find this homework to be pretty quick, even though it may look like a lot of problems. I think you'll move through it quickly. I think it's applying information that you are already very on top of with just a few new pieces of information, and I hope it goes well. So just 2 videos, I think, is all I did for this lesson.